perhaps in a month, perhaps even in a week in some cases. Start with those input variables that are readily available, maybe the ones that you expect to have the biggest impact. Code out that data set, create a model, but then, especially if you find that model to be useful and it's being used, then come back to it and maybe go and look into and add in more features, but create that minimum viable product model first, get value right away, and then iterate from there.
Yes, I'm hearing you say that we just need to complete the thought.
Hi everyone, this is Brian Hamline with Value Driven Analytics, coming to you again with a very special guest. I'm here with Gary Spakes of Ridge Trail Ventures, and I'm so excited to continue our conversation. We just had a conversation recently about starting with SQL and doing some data manipulation and where you can go from there. The end goal, ultimately using analytics to make a better data-driven decision. So I'm excited to continue the conversation with you now.
Yeah, I'm excited to continue as well. You know, we talked last time around the analytics lifecycle of data preparation and exploration into building an analytic model, being able to validate that model is good, and then putting that model into production so you can monitor it and see how well it continues to run. And where you've been on your channel up until this point is in the data preparation phase. But, you know, I want to shift that to data exploration.
Absolutely.
And that's moving us down that chain in the analytics process there instead of just playing with the SQL components. And when I think about exploration for the goal of building an analytic model, there's some things that we have to think about in how the data is shaped.
Yeah.
And a couple of terms that I want to throw out that people may not realize that they need. The biggest one, when we're shaping data to get it to the point for analytics, we're using those descriptive analytics, historical stuff, the statistics and things like that, to build this term called a target variable.
Yes.
So people may not know what that means. What's a target variable? So can you talk a little bit about what that target variable is and why it's so important? Add one of that, and you have one of those or multiple of those in your data sets that you're building.
Yeah, we're really getting to the meat of data science when we talk about a target variable. Just taking a little bit of a step back to put it in context. When I think about creating a data science model, I want to answer 3 questions up front. One is, what does one row represent in your data set? And so usually that's the same in your training, in your test, and your score data set.
Wait. Different. Okay, so now we're talking different types of data sets, training and testing and scoring and validating. That's probably
further along.
Probably a little bit further along. So let's just talk about what does one row represent first and foremost.
Yeah. So that's a starting one. Probably I would answer that question before even thinking about your target variable. It starts with the business problem, the business challenge. So if your challenge is my sales team, I'm a sales manager, and my sales team has thousands of customers and prospects that they could contact, and we just want to help them contact the one that is most likely to buy, or again, like we talked about in our last video, the one that a sales call would have the biggest incremental impact on their ability to buy, even better to what the business challenge is. I look at that challenge and I think, okay, you've got a list of prospects and customers that you could potentially reach out to. My mind goes to, I think our data set needs to be one row per prospect or customer, perhaps a combined data set of those, anyone you could possibly reach out to. That's what one row is going to represent. Now, I might...
Or another type of problem, my son just gave my daughter for Christmas an OBD reader.
Okay.
For her car. Although she could put it in and see if there's something going on. So, it's not only sales or stuff like that, there's manufacturing implications and retail. I mean, there's all types of problems like what are some of the characteristics that we need to measure to see if a car is going to break down in the next 1,000 miles or 10,000 miles? I mean, is that a good example?
That is a great example. So if I were facing the problem of creating that product to create a prediction of what the problem is, now I'm not as familiar with that particular use case, but just thinking on the fly here, I might look at, you need a training data set. So maybe there's a list of problems in a set of body shops or a set of repair shops, and they've brought in cars, and there are certain, maybe they take reads on different things that device is able to measure.
Heck, our battery's always gone bad. You go, is it the battery or is it the alternator? And so there's tons of things like that.
So every single one of those instances, go on to your target variable now. The target variable is what did the mechanic actually deem the result was? What was the actual issue? That would be your target variable, what you're trying to predict in that case. Your input variables are the things that the device was able to read, right? Because you're not going to have access to the end result when you're actually using that device. All you'll have is what the device is able to read.
So you're telling me that a target variable isn't just the yes or no. Did it break or did it not? Did they buy or did they not buy? It could be a multiple choice type of thing, or
yes, or a continuous variable.
Wait, explain that. What's a continuous variable?
Yeah, a continuous variable is a variable that can have a range of values. Like you said, it's not just, it's this problem or not, they bought or not. It's a continuous variable. They have all kinds of distributions. We like it when it's normally distributed. There's a lot of models around that, but there's also models for other types of continuous.
Okay, so now you said distributions. What's a distribution? Are you just like counting the number of times something happens, or are you looking at a range? What is that?
Yeah, maybe counting the number of times it has different values or values in certain ranges. So a normal distribution or a bell curve, it shows you how often maybe is the value of I don't want to use sales because I keep using that value. How often do you spend $50 or maybe $50 to $100 versus $100 to $150 versus?
Okay, so like when you go out for dinner, you're spending the $50 to $100 range if you're taking your wife to a nice place. So right, that's up there.
Yeah.
Or your significant other. Then there's the fast food side of the house. You're in the lower side. You might spend a whole lot more there, and you may have the count kind of go like this, or not only counts, but it may be the total spend. That's right. You're trying to do a curve, and you're breaking those up in ranges. And with this being 2024 and the presidential election going up, are they looking at demographics between 25 and 34 or 35? Yeah, age range, things like that. Right. Those are things that you could actually look for distributions and look at counts and populations or whatever you're trying to marry or trying to figure out. And that would be the distribution, that continuous variable that you're looking at. Is that fair?
Exactly. And as you can imagine, there's all kinds of shapes of distributions. So there's different models for that. Even the binary indicator variable, like whether someone bought or not, or something went wrong or not, something that has two outcomes, that's technically a distribution as well. And so if you're using regression, you would use a special type of model for that, a logistic regression that is tailored toward a binary indicator variable. And what we were talking about before with the multiple outcomes, it's not really in the case of what went wrong with my car, it's not a continuous distribution. It's not a range of values because it's like a character variable. Okay. Like you said, your battery went wrong or your alternator is messed up. And so with that, if you have multiple outcomes, there are classification models tailored to multiple outcomes. Even using logistic regression, the way you could potentially model that is, was it an alternator issue or not? Was it a battery issue or not? And all your different outcomes, you'd have a different score for each one of those, and your final prediction would be the one with the highest probability.
Is that why in data we see a lot more codes for things as opposed to descriptions for things? Because it's easier to grab that data and sort it and count it if it's a code, as opposed to looking at a big text stream where I may say the alternator went bad, and then the next tech that comes along goes alternator bad, because the alternator went bad, the text isn't the same as, we're doing some of that text mining to figure that out. But is that why, alternator is bad or alternator bad, and you put code 101 on all of those? Is that why people are using codes for stuff like that as opposed to just text values?
Well, it could be, and there's a lot of reasons for codes in databases, in analytics. I would say maybe the code use, just from my perspective, and again, there could be a deeper use understanding of, or a deeper meaning of using those codes. But sometimes you use a code because uses a key in a database, and that 101, that's 3 digits, versus the description of the item, that the real problem might be 100 digits to describe it, or maybe 50 digits just to get the name of the problem out there. So it saves space, and then you might have a lookup table to figure out to translate that.
Yeah, that's a whole different conversation around data modeling that we can have, and the use of third normal form, and how data is typically in IT organizations are shaped for optimal storage versus problem solving, right? That's out there. But, we've talked a bit about target variables now, continuous or binary indicators, yes and no, stuff like that.
Yeah.
And there's another term that I want to talk about in the data preparation, the data exploration phase, because that's what we're talking about. That's called an association analysis.
Okay.
And that's based on what your problem is. There are certain columns in your data that can help predict that target variable.
Yeah.
Talk to me a little bit about what that is.
Absolutely. Well, again, 3 main questions. What does one row represent in your data set? What is the target variable? That's the thing you're trying to predict or explain. And what you're talking about now with the association analysis is where the third thing you need to figure out, to determine for the use base. All of this is tailored to the business problem, use case you have. And that's, what are my input or predictor or independent variables? There's a lot of ways of describing them. So where the association analysis comes in is how the input variables, this is going to be a wide list. Some cases it might be a few variables. Some people might brainstorm 100 different variables that you think could be predictive or prescriptive, or help explain why your target variable is one value in one case and another value in another case. How can we use those input variables to predict or explain our target variable? That's the association analysis.
Okay, so let's take a rudimentary sales case.
Yeah.
Then, so our business problem is, how much sales are we going to have next month?
Yes.
We're looking at target variables, and you have to use historical data for that. So you're looking at, what were my sales last month or the month before, or what are my sales for a specific product? That's for last month. And I want to look at, let's say I'm at a grocery store and I'm buying potato chips.
Right.
So what are my sales last month? But some of the independent variables for selling potato chips may be, did I buy soda associated with it? Or was there a big sporting event that I was having a party for? Or am I going on the right track on, these are like independent variables?
Yeah. Well, and it depends on your use case. Is your use case to be able to predict sales for potato chips at a high level, like at the grocery store level? Or is your use case, I want to predict sales of potato chips at an individual customer level, so I can perhaps decide whether I'm going to give them a coupon or a marketing advertisement for that particular product.
Oh, wow. That can be kind of crazy, because I get all this spit out coupons.
Yes.
When I'm checking out at the grocery store.
Yeah, that would be the second use case. That would be the second setup. 1 row per customer, basically.
Yeah. So you're telling me that as I'm scanning my stuff, there's something running in the background that says, oh, because I put in my code, my valued customer code that they have, there's something running in the background that says, well, this is what he's buying, and I want to entice him to buy something else, so I'm going to spit out a coupon for this other thing.
Most likely that is perhaps even at the transaction level. Maybe it's 1 row per visit or transaction. And perhaps the target variable is, what is Garen most likely to buy next? And it's all being trained based on historical data.
Not just my data.
Not just your data.
But it could be your data,
right,
as well.
Or especially shoppers that have bought similar things to what you bought or have a similar profile. Exactly.
Okay, so that goes back to the distribution. Which category am I falling into? in all of that?
Yeah, most likely, those are going to be qualitative things. Which product are you going to buy next? So it ends up being a lot of binary indicator variables. Is Gary going to buy potato chips next? Is he going to buy hamburger next? All the different options that the grocery store has, they're running a model on that and have a score, and they're going to show you perhaps coupons that are either the most likely thing that you'll buy next, or again, going back to the sales example, but applying it to products, what product would a coupon add to your incremental profit driven by the grocery store by giving you a coupon versus if we don't get any coupons?
So what you're saying is exploration and preparation. It could be iterative. I may get to a point where, I don't actually have the right stuff in my data set, so I've got to go back and prepare again so that I can explore because of the problem that I'm trying to solve.
Yeah, you're hitting the nail on the head. So many analytics and data science teams will, I guess you could call it analysis paralysis, but they will spend, honestly, I've seen teams spend more than a year creating a data science model, and it's because they try to get that. They'll brainstorm a list of input variables, which is a great place to start, but they'll think, well, I've got to code all of these out and to get all of this information, maybe some of it's third-party information. It's going to take months to work on a legal deal and get everything together with this third-party vendor, where they could, perhaps in a month, perhaps even in a week in some cases, start with those input variables that are readily available, maybe the ones that you expect to have the biggest impact, code out that data set, create a model, but then, especially if you find that model to be useful and it's being used, then come back to it and maybe go and look into and add in more features, but create that minimum viable product model first, get value right away, and then iterate from there.
Yeah, so I'm hearing you say that we just need to complete the thought and not. I think perfect is the antithesis of good in this case.
Yeah.
Where you spend so much time trying to get it perfect that you're missing some of the boat that's there.
That's right. Happens all the time.
Yeah. So this has really been an interesting discussion around data preparation. Data exploration. I keep getting those mixed up for some reason. Because my background is DBA and data preparation and data modeling and systems modeling and things like that. Not necessarily what you're talking about. I want to close with this question for you, Brian. When we're looking at exploring data for solving a problem, are we really looking at science or art? Is it a science or is it an art?
Oh boy, good question. It's a little bit of both. People think of analytics, they don't think of creativity. That's not the first thing people think of, most people, when they think of analytics.
Well, you're telling me that it is.
It is.
Okay.
It is, and that's where the art comes in, and that's where those three things that you're determining when you build a model, one row represent, what's your target variable, what's your independent variables, figuring out those for your use case for the business problem is a creative process. It's not just a mathematical formula that you calculate to figure that out. It's solving a word problem. It's coming up with a creative approach to it. And the analysts that do that the best are the ones that are creating valuable models. So that's the art part. The science part is from there. I've figured out what one row represents. I figured out my target variable, my independent variables. Now it's more science, coding that out, running the model, applying the mathematical formulas. A lot of times you don't even have to know the theory behind it. That's coded out for you in Python or in SAS, these advanced analytics platforms. And then I suppose coming full circle, it comes down to, well, and how am I going to use that? And that's maybe where the art comes back. So it's like art designing the approach, science executing on the approach, and then art again implementing and turning it into a real decision that's being made from there.
Yeah, interesting. Hey, my name's Gary Squakes from Ridge Trail Ventures, and I'm just really excited to be here with Brian Amrine from Value Driven Analytics. And you need his expertise, so give him a shout, Brian.
Yeah. Thanks, Gary. It's been a pleasure. I've really enjoyed this discussion. Definitely recommend Ridge Trail Ventures, and I'm looking forward to partnering with you as well. If you enjoyed this video today, please consider liking the video, Subscribe if you want to see more trainings in general on the types of techniques we've talked about, but also conversations like this where we talk about where the rubber meets the road when it comes to analytics techniques. And please leave a comment if you have any questions for Gary or I, and we'll get back to you as soon as we can. Thanks again for watching, and I'll see you in the next episode.